Hey there, I'm Hemanti.
Hi, I'm Shreya.
So for our second video assignment, we'll be talking based on the contents from Security Week.
We'll be going over encryption, modes of encryption, and types of encryption.
So as we all know, the internet has become a really populated place now.
There have been many reports of scams, people's accounts being hacked, and there have been problems cropping up in the cyber world.
So it is really essential for us to actually know how the security on the internet works so that we all have a safe browsing session. Join us on our adventure.
So let's talk about encryption. Encryption is basically the conversion of plain text into ciphertext. Plain text is something that can be understood by everyone. For example, if I say, "Hi, my name is Shreya," so anyone who can understand English can understand what I said. On the other hand, ciphertext is something that is complete gibberish to a common man. Only a person with the key can understand what is being said after decryption. Encryption occurs at different communication levels with different types of protection and implications. Hence, there are two modes of encryption. The first one is link layer encryption and the second is end-to-end encryption. Also, there are two types of encryption. The first is symmetric encryption and the second is asymmetric encryption.
So I'll be going through link layer encryption for now. So basically in link layer encryption, all the data will be encrypted along a specific communication path. And what I mean by all the data is basically like users information, headers, trailers, addresses, and routing data. So what this does, it helps to prevent any eavesdroppers or a packet sniffer to know what's going through your data, which basically makes it more secure for you to send something. And this encryption is normally provided by all the service providers, which is incorporated into a network protocol. And as we know, when we want to get a packet from a source to a destination, there'll be multiple hops in between before we actually get it to the destination. So for this data, we'll need to decrypt our message in every hop and re-encrypt it until it reaches its destination.
So let's talk about end-to-end encryption. In end-to-end encryption, the headers, addresses, trailers, and routing data are not encrypted. This enables attackers to learn more about the data and where it is headed. The term end-to-end encryption implies that the data is encrypted at one end and decrypted at the other end. So the main advantage of end-to-end encryption over link layer is that in link layer encryption, the data needs to be decrypted and re-encrypted at every hop throughout the journey. So the key to decrypt that information is provided to all the hops. This makes it easier for the data to be stolen at each of the hops. But in end-to-end encryption, it is the key to decrypt the data is available only to the end users. Hence, there are less chances of your data being stolen.
Now we'll be going over the types of encryption, which is symmetric encryption and asymmetric encryption. I'll be going over the symmetric encryption. So as the name goes, symmetric. So the key used for encryption and decryption process will be the same. So for both the communicating parties, they both have to agree upon a same and a common key so that the encrypting party could encrypt it and the decrypting party could change it from ciphertext into plain text so they know what the content of the message is. And there are few common and well-known symmetric encryption algorithms, which are AES, DES, Blowfish, and Skipjack. And in comparison to asymmetric encryption, we normally prefer using symmetric encryption for bulk data.
Continuing with what Hemanti said, I'll be going over asymmetric encryption. So asymmetric encryption utilizes two keys, a public key and a private key. The public key is used to encrypt the data and only the holder of the private key can decrypt the data. This ensures confidentiality in communication. Many secure online transactions use asymmetric encryption to establish a secure channel. For example, SSL uses asymmetric encryption to provide communication channels in a secure and efficient way. Given enough computing resources, we can essentially break both asymmetric encryption as well as symmetric encryption. Even though symmetric is more efficient than asymmetric, it can be easily broken by brute force attack, in which you basically try out all the combinations in order to break the code.